Okay, we are continuing to separate insoluble liquids or insoluble solids. This time we're talking about decanting or decantation. So other than filtration, if you don't have a filter paper, sometimes you can use decanting. Decantation is a very simple topic and simple experiment to be done. You can done it even by yourself. What is there is that in this form we want to get our solid, or sometimes you want to get both your solid and your liquid. You want to get your liquid. So what basically you're going to do is that you're going to mix the mixture with a mixer. For example, there on the board with a mix of sand and water. After having the mix of sand and water, you allow it to settle. Okay, after setting at the end, you're going to see that the sand will settle at the bottom. After settling at the bottom, you're going to have the pure liquid on top. Then you can easily pour it down and pour out all the liquid, and you're going to remain with your solid. You either collect your liquid and remain with your solid. That's about decantation. Let's try to look at more in a dramatic way. Okay, a good example of decantation, we've got a hand there and a test tube. The test tube, there's the mix of sand and water, and we shake it thoroughly. After shaking it thoroughly, we allowed the solid particle to settle at the bottom. Then you can see that we were able now to pour out this liquid part and remain with a solid particle which you wanted to remove, and you correct your liquid. That's how simple decantation is. You can do it by yourself, so you can separate whatever you want to separate using this method. It's one of the easiest method one can do even at home, and it's safe. Let's try to explore more on other separation technique. Okay, now we are separating the immiscible liquids. Do you remember, guys, what we talked about when we said immiscible liquids? We said immiscible liquids are the liquids that can't be mixed. For example, if you've mixed oil and water, of course you know that cooking oil and water, they can't mix. So those are immiscible liquids. But how can you separate this immiscible liquid? Well, this separator you're seeing here in front of you, that's a separating funnel. A separating funnel has got an opening on top there and a tap at the end. What you do, you just pour your mixture. Then of course it's going to show us different layers. We can open the tap slowly. After opening the tap, we look at the liquid that is coming out through the layer. In this case, we depend more in the layer. Let me show you the setup apparatus, how it's done basically from the book that using. And there we go. This is the set apparatus for the immiscible liquid that's using the separating funnel. As you can see here, we've got our clamp stand holding our separating funnel together. We've got a stopper there just to avoid substances from dropping in, because we have to maintain this as pure as possible. We've got different layer. In this case, we had the mixture of oil and water. Let me mention that you can also separate even more than two substances. They can be even before, as long as they are immiscible, they don't mix, and also they've got different densities. Why do you think we need them to have different densities? It's because if they've got the same density, then they're going to be basically on forming the same layer on the same spot. For example, they can all be here because of the same density, or they can all be in the first layer. So they have got two different densities. The density should be different, then also they should not be mixed. So if you said to them, okay, you put something at the bottom just to collect what you have. Well, in this instance, I'm using a conical flask. So what will come first is the heaviest, because the heaviest is the one which is on the bottom. For instance, oil and water, we know that water is denser than oil, so water will settle at the bottom. By opening this tap that I have, opening the tap, I'll first collect all the water will run through my conical flask. Here's just an example of the end whereby all the water has come out, and what you've remained in is oil. You just have to close your tap. Therefore, you can go and use your oil, and there is your water. That's all about the separating funnel. Remember, use this when you want to separate what immiscible liquids. Let's keep on exploring on the separation techniques. They are so interesting, and this should be tried in a laboratory. Yes, we are still with the immiscible liquid, how to separate them. And the next experiment that we have, or technique that we have, is centrifuging. Okay, so when you look at centrifuging, the definition what we have here is that it's used with small particles that are insoluble and sprayed throughout what the liquid. Okay, okay. Basically that's what we are talking about. You've got some solid that are spread out, and they're very tiny, in a solution. And centrifuging depend on the force that you are using. uh, for this instance, we've got some test tubes. Okay, these are the test tube with all your mixture there inside, with your mix. And of course you can see that we've got some layer at first. We never had this layer, so we had some insoluble solid which form at the bottom. But once you start spinning this, you spin it, all the heavy will going to settle at the bottom, and the light one will be there on top, and you're able to pour out while you've remained with what you've remained with your insoluble particles that you wanted. Okay, let me try to show this also from a book. Maybe it can be too clear for you. And there we go. That's about the setup of the centrifugal machine, which you have this what you're able to see. That's a centrifugal which we've made up. But the actual process sometimes is also called sedimentation. Then you might be asking yourself, what does sedimentation mean? What is this? So basically, when talk of sedimentation, we're referring to the process, or we're describing the settling down of the solid particles in a liquid. And that when they settle, we're trying to produce flocculent, or coming up with a clear solution on top, which can be tapped off. I'll repeat what I've said. I said sedimentation is a term used to describe the settling down of a solid particles in a liquid to produce a flocculent, leaving a clear liquid on the top, which can be tapped off. So now, what are we talking about in this example that I have with you? We've got, okay, you can see the metal box was inside, then it was we've got the direction, something was rotating. What we put in the mixer, we had chalk. When you mix chalk with water, chalk doesn't dissolve. Okay, slightly can show some whitish color, but what is actually there, you're going to have small suspension of chalks inside. So when you start to rotate this thing, you start to rotate the tube here at a fast rate. For example, here we are connected to an electric motor at a very fast rate. What happens that the heavy particles, in this case it will be the chalk particles, are going to settle at the bottom. Once they settle at the bottom, you can remove it, and just the kind, you pour out the light solution which is on top, and remain with your solid particles at the bottom. This is about centrifugation and sedimentation, and mostly it's used in clinics when you want to separate blood component. That's about Sedimentation or centrifugation. Let's explore another separation technique. There we go. Another simple technique that you can use and which is not even dangerous to yours. That's magnetism. When talk about magnetism, basically we're talking about the process which you use to separate metals from non-metals, or separating magnetic substances from non-magnetic substances. You know what happens when you use a magnet to attract a metal bar? Usually it will be attracted. But what happens when you get a magnet and a paper? A magnet can't attract a paper. So most in some instances you find like the magnetic substances have combined with non-magnetic substances. And the best method to use, that's magnetism, because we know magnet is going to attract the magnetic substances. Example, what you have here, we had a mixture of iron fillings and sawdust. Okay, among iron filling and sawdust, which one is attracted by magnet? Of course, iron filling is attracted by what? By the magnet. And sawdust can be attracted. It's magnetic. After mixing sawdust and non-magnetic, we had put it in a petri dish, as you have seen here in a petri dish. Then we came with our magnet. Just putting a magnet on top, even just inserting the magnet inside there, one end, we are sure that the magnetic substance, all the magnetic substances are going to be attracted to the magnet, leaving out your sawdust. This magnetism method has been used largely in industries to separate, in manufacturing industry, to separate magnetic materials from non-magnetic materials. That's about magnetism, a very good separation technique which you can do even at home on your own. Just look for a magnet, try it out, and there are a few the interesting part of magnetism. And another separation technique that we are going to do is that's sublimation. Okay, a very good method, but critical. It needs you to study in details substances that are able to sublime and those that cannot able to sublime. But first of all, let's try to redefine sublimation. We said sublimation, this is a change of state from solid direct to gas. Then deposition, yes, sublimation. And we said sublimation and deposition, they are opposite of each other, right? So if we talk of sublimation, the change of state from solid to gas, then when we talk about deposition, that's a change of state from gas direct to solid. It doesn't involve liquid. So there are some substances that sublimes and others don't. Take for instance what you have here. We had a mixture of iodine and common salt. Now, when talk of iodine sublimes, meaning when you heat it, when you heat iodine, okay, when you heat iodine, it will change direct from solid to gas. That's about iodine when you hit iodine, but common salt doesn't do that. So if we had a mixer for iodine, for instance, like what we have here, iodine and common salt, we mix them. Okay, we've got our own evaporating dish with the source of heat, which is the Bunsen burner, where the wire guys for smooth heating. Then we also the glass filter funnel here, inverted. It was inverted, and our clamp stand there. After we start heating, I'm sure you're aware that now iodine solution will begin to sublime, meaning to be changing its state from solid to gas. But there we had our funnel, and the funnel is going to trap all the iodine solution. When the iodine gas here is being trapped, it will be cooled and it will change from the gas state to solid to back to solid. Hence, you've got your iodine solution there. sorry, not iodine solution. You've got your iodine there trapped, and you've corrected it. And this is a method which you call what, the sublimation. Very cool, very clear. You have to use this. Remember, the most property of iodine sublimation is that the substances must able to sublime. Okay, distillation. And when we talk about distillation, there are basically two types of distillation. We've got that is simple distillation and fraction distillation. But first, let's start with simple distillation. As the way it sounds simple, it's something which should be simple. Okay, that's about this simple distillation. But what is simple distillation exactly? That should be our question. So when talk about simple distillation, we are saying that this is the process of vaporizing a what? A liquid and condensing the vapor. Please pay attention to this, right? We are saying that simple distillation, actually we are just vaporizing. Remember, if we talk of vaporizing, we are saying that the changing of a liquid to gas. So simple distillation, we are changing a liquid into a gas, then changing that gas back changing that gas back to liquid. That's about simple distillation. So we're saying that the process of vaporizing a liquid and condensing the vapor. That's what we are talking about. Now, this process it can be irregular at some point. What I mean, they can't be a smooth boiling. So for us to have a smooth boiling where it's being heated regular, because we're involving heat source, as you are going to see from the diagram. For smooth boiling, we have to add porcelain, right? Porcelain, or sometimes just call it ant bumping, because we don't want it to be bumping when it's boiling. We want it to boil throughout the container. Then that liquid you're going to collect as a vapor, now that vapor which you're going to condense is known as distillate. So distillate is a pure liquid that is collected in simple distillation, and it has got many uses, main uses. So some of the uses of distillate is medicine, also can be used in car batteries. So in medicine, for us to clean medical utensils, we must use distillate. Remember that distillate is pure, it's very pure, because it's a vapor that has been corrected and condensed. Then it's also used in car batteries. Now let's look more on the diagram of simple distillation and how it is prepared, or how it's set up. Okay, there we go. This is our diagrammatic presentation for simple distillation. Remember that too, there's fraction distillation and simple distillation, but this is simple. I think you can see from our operator that this is very simple. You just got your clamp stand there, the round bottom flask. Last time I explained on the use of round bottom flask, that most is used for heating. Okay, and we are heating here in the round bottom flask, and we've got porcelain inside here, or anti-bumping granules. This is to make sure that the boiling is done in a regular way, the smooth boiling. Then an example of what we wanted to distillate here were the potassium magnet. Potassium magnet 4 doesn't distillate. So basically in potassium magnet, if it's a solution, of course there's water. There's that water which you want to collect back, okay, or that liquid which you want to correct back. Then we're going to have the Liebig condensers. Some other books will explain it as condenser jacket. That's what is here. Pay attention to where water is getting in. So water is getting in from the bottom part, and it's coming out from the top part, because sometimes I've checked some papers whereby they'll tell you where water is coming. So water is coming from the bottom and going out from the top. What do you think is the reason why water is coming in from the bottom and coming out from the top. Please try to think on those areas. Okay, this is our library condenser. Then we've got what you're collecting. Sometimes we normally recommend that use a conical flask here to avoid the vapor from escaping, unlike the way it is right. If you use a conical flask, the vapor is unlike that it will escape. Here's Bunsen burner wire gas. Okay, let's now start to heat. After opening your Bunsen burner here, you begin to heat. There's a degree of temperature in which all that liquid, apart from potassium magnet, because potassium magnet doesn't distillate, it's going to evaporate. As it's evaporating as a gas, while it's passing here in the library condenser, it's being cooled because the water that's getting in here, it's cold, so it's being condensed back. That vapor here in library condenser is being condensed back to liquid, and it's the one which is dripping here, and you collect it as what? As your distillate. That's about simple distillation which we're talking about. Let's try now to differentiate it from fraction distillation by exploring more on the fraction distillation.